Hello everyone, welcome to In 5 Minutes. In this video clip, we will discuss one numerical on frequency modulation. The question says in an FM system, when the audio frequency is 1000 Hz and AF voltage is 2 volts, the frequency deviation is 4.8 kilohertz. If the AF voltage is raised to 10 volts while the audio frequency, that is AF, is dropped to 500 Hz, find the modulation index in each case. So basically the question is about finding modulation index in each case. So I'll first consider case 1. In case 1, we are given the audio frequency which will be FM equal to 1000 Hz. We are given AF voltage equal to 2 volts. AF voltage is nothing but VM. So I'm taking VM equal to 2 volts. And in that case, they are saying delta F, the frequency deviation, comes out to be 4.8 kilohertz. So let us find out mu f1, the modulation index 1. The modulation index 1 will be nothing but delta F upon FM. Delta F is 4.8k and FM is 1000 Hz, which is nothing but 1k. So the first modulation index comes out to be 4.8. It was very straightforward. First part, delta F was given, FM was given, so all we had to do is take the ratio. Now in the second part, we have to find modulation index again, but this time they have changed few things. AF voltage is raised, so now the new value of VM is equal to 10 volts and AF is dropped to 500 Hz. So new value of FM is nothing but 500 Hz, and they have not mentioned anything about delta F. So the question is what delta F value we should use. Obviously we can't use delta F equal to 4.8 kilohertz because that was given only for case 1 part. We have to find out delta F for case 2. Now delta F will not remain constant. We have to figure out which value will remain constant even when we go from case 1 to case 2. It is that value I can use in case 2. So if you remember, we had defined something called as frequency sensitivity KF of frequency modulation process. KF will always remain constant for the given system, and hence KF will be something that we find in case 1 and we can use the same value in case 2. KF is nothing but delta F by VM. This is the expression of KM that we have defined. So for the first case, delta F was equal to 4.8k and VM was 2, and therefore KF comes out to be 4.8k by 2, which will be 2.4 into 10 raised to 3. Now you can see the units of KF will be nothing but delta F is measured in Hz and VM is voltage, so Hertz per voltage. So I can use the same KF. So this KF we will find in first case, even though it has not been asked, but we are going to require it in case number 2. So in case 2, now we say that to find delta F, we use delta F equal to, so delta F will be nothing but KF into VM. You can see delta F will be KF into VM, but which VM we will use here? Obviously the new VM. KF will not change, so 2.4 into 10 raised to 3. So just to avoid confusion, I can call this as VM2 FM2 and delta F2. So delta F2 will be KF into VM2. KF remains constant, but VM2 that I'm taking is 10 volt, and therefore delta F2 becomes 2.4 into 10 raised to 3, which will be 24 kilohertz. Once I get delta F2, I can find out mu F2, which will be delta F2 upon FM2. So that's 24k divided by FM is nothing but 500 Hz this time. So 24k divided by 500 Hz will be nothing but 48. So that will be my value of mu F2. So mu F1 was 4.8 and the effect of increasing the voltage and decreasing the frequency changes mu F to 48.